Alrighty, ladies and gentlemen, we are here for our last class. I should say first lesson of our last unit. Okay, it's pretty short. I think it's only 3 or 4 days. Okay, it has to do with what's called sequence and series. Okay, all the homework is posted to Schoology. I took pictures. I actually assigned questions from the textbook, but I took pictures of the textbook and then I provided a detailed answer key that I worked out. So you guys can use that to check your work, okay? Basically what we're gonna be working with is, first of all, sequences, okay? So when we have a collection of objects, generally numbers, right? In an order, right? Where you have a first item, a second item, a third item, a fourth item, so on and so forth. That's called a sequence, right? A sequence of items, okay? You are familiar with sequences. There's like the days of the week, the months of the year, right? So there's the first day of the week, the second, the third, the fourth, they're in an order, okay? In algebra, you think of a sequence as a function, okay? Now here's the biggest thing. When we work with a sequence, the domain is the set of consecutive integers, okay? So consecutive means in order, all right? Now, if it's not specified otherwise, your domain always starts with 1, okay? So your inputs, your x values, always starts at 1, okay? And then you get the next consecutive integer, so it's 2, 3, 4, okay? Now, when we work with sequences, I don't know who decided this, instead of using x, we use n, okay? So our domain is always going to start with 1, unless they tell us something different, which I'll be honest, most of the time they don't, okay, for our purposes. So we're gonna start at 1, 2, 3, 4, okay? And then the range is going to be in this kind of different format, okay? Where you have a sub 1, a sub 2, a sub 3, a sub 4, okay? And this guy is called a sub n, okay? The sub just means corresponds to the domain, right? So here, a sub 1 is just the first term, the second term, the third term, the fourth term. So this is, the domain is where it is in the sequence, right? The first, the second, the third, the fourth. And a sub 1 will be some value, okay? So if I look at these guys, these are sequences, okay? So they're numbers in some sort of order, okay? Usually there's some sort of pattern, okay? But you can see here, 2, 4, 6, 8. This is called a finite sequence, meaning it has an end. And then this is called an infinite sequence because it goes on forever, right? You see the dot, dot, dot. Okay, so this doesn't end. All right, and if you take a look here, using our notation, the number 2 would be a sub 1, the number 4 would be a sub 2, this would be called a sub 3, and this would be a sub 4. So the subscript here just tells you where it is in the sequence. So the fourth term in the sequence is 8, okay? So if you take a look here, this is what the first part of your homework is going to be, okay? I just want you to practice using the rules. So remember, this is a sub n. So to find any term number, a sub n, any n, we're gonna follow this rule. So we're gonna find the first 6 terms. So we are going to find the first, right? Then the second, the third, the fourth, the fifth, and then the 6th. And basically, you're just gonna plug those in just like you would with x anytime, okay? So if I take a look here, this is like my term number, okay? All right, and then I'm gonna find, this is gonna be a sub 1, a sub 2, a sub 3, a sub 4, and then a sub 6, okay? So I'm gonna plug in 1 first. So this is gonna be 2 times 1, plus 1, and that gives me 3. So that's my first number, okay? Then 2 times 2 plus 1, right? I'm plugging in that 2 in here. So that's 4 plus 1, so that's 5. Then the next guy is 2 times 3. So I'm just inputting the n value, right? Whatever the term number is, plus 1. So that's 7. Then a sub 4, I'm going to plug in the 4. So 2 times 4 plus 1. And that gives me 9. And then 2 times 5 plus 1. And that gives me 11. And then 2 times 6 plus 1, me 13, okay? So that's my first 6 terms in that sequence. I can do the same thing here. We're using exponents like we've been using in our other units, okay? So to find a sub 1, so I'm gonna plug in 1, 2, 3, 5, 6, right? So this is -1 to the first, -1 to the second, -1 to the third, -1 to the fourth, -1 to the fifth, and -1 to the sixth. So basically I'm just plugging in the exponent here. So -1 to the first is -1. Then -1 squared is -1 times -1, so that's +1. So then -1 to the third, and you could put this in your calculator with the parentheses, would give you -1. And then -1 multiplied by itself 4 times, right? Would be 1, and then -1, and then 1, okay? So there's your first, your second, your third, your fourth, your fifth, your sixth. So this is again called a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6, okay? I'm not gonna do these. This is the same exact thing as what I just did. If we were in class, we'd do those, but you guys can see we're just plugging in. So your first couple, I think 13 and 17 are like that, okay? Then, okay, the only one I'm gonna do is number 5. So take a look at number 5 here. We have one like this on the homework, right? We're finding the first, the second, the third, fourth, the fifth, and they just asked for the first 5 in the instructions, so we're gonna do that. So to get that, I'm gonna have 1 squared plus 3, right? So 1 squared is 1 plus 3, so that's 4. So that's a sub 1, right? Then 2 squared plus 3, right, would be 4, so that'd be 7, and that's a sub 2. Then 3 squared plus 3, right, would give me 9, 12, right? So that's a sub 3. Then a sub 4, right? I'm going to plug in the 4 for n. And then that gives me what? 16, 17, 18, 19. And then 5 squared plus 3. And then that gives me 25, 26, 27, 28, 28. Okay? So, and that's a sub 5. Okay? So make sure when you write this a sub 1, a sub 2, a sub 3, you're using the subscripts like we did with logs. Okay? Good, okay, so that's just plugging in, okay? Eventually we're gonna write those rules. Oh, look at that. Now let's try writing a rule. So we're gonna write this in a sub n like format, okay? Here's the ones that I want you to look at, okay? We're gonna focus on these two, okay? So writing a term, right? Terms of a sequence may have a recognizable pattern. So these should have patterns, okay? This one's a little bit harder to see, okay? But if you look at these guys, right, there's definitely a pattern here. Each time, if you think about it, we're multiplying by -1. Isn't that what we're doing when we raise it to a power? So this is a pattern of multiplication. If you look here, 3, 5, 7, 9, 11, 13, hopefully you can see the pattern here is addition by 2, okay? So we're gonna talk about writing the actual rules for these two, okay, ourselves. So these are the two patterns, right? A particular value is added, right? It could also be subtracted, but added to each consecutive term, right? Or each term is multiplied by a constant, okay? So if I take a look at these guys, right, I can see 3, 4, 5, 6, all right? I am always writing this in terms of, right, how it compares to, right, what the pattern is. So I'm going to look for my pattern. So if you look, I can see that's +1, okay? So there's that first pattern that you're going to, common pattern that you're going to look for is the addition of 1, okay? Then So I see the addition of 1, all right? And then I'm gonna think about, this is my first term, right? And my second term, and my third term, and my fourth term. That's your n, isn't it? So we're gonna always write this in terms of n, all right? Now, if you have an addition pattern, here's what you're gonna do, okay? The way you're gonna write it is, you're gonna have a sub n equals, this is kind of like your slope. This is how it's increasing. So if you remember, back in our first unit, way in the beginning of the year, okay, slope always goes in front of the x. So instead, I'm gonna put it in front of my n, okay? So my slope is 1n. And then if you remember, we always had the b value, right, is y equals mx plus b, and b was your beginning value. Now, your beginning value is never your first term. It's actually your 0th term, okay? So to find the 0th term, you can see the pattern is +1, right? Well, what number would come right before 3 but fit into this pattern? Well, if I want to go in the opposite direction, I'm going to subtract 1, right? So that means this 0th term should be 2, right? So now I'm going to add the 2 here. So this is your 0th term, which is kind of like your b, and this is your increase, and it could be your decrease, which is your slope. So we're kind of increase or decrease, okay? So that's your formula, right? Now, if you think about it, right? If I plug in a 1, 1 times 1 is 1, plus 2 gives me 3, right? 1 times 2, that would be my next n, right? Like we were doing it up here, would give me 2. 2 plus 2 is 4. Ah, so this is my rule, okay? So that's a rule that you need to. And then write the rule. Okay, they wanted also the next term. So here the next term would be a sub 5 would be 7, right? Because that would be our 5th term. That's our next one. Here's this. And to describe our pattern, what are we doing? We're adding 1 each time, okay? So if you're adding, you're going to write it like this, right? The increase or decrease is your slope, and then you have your 0th term, okay? Now, if I look at this guy, I go from a negative to a positive to a negative to a positive. So I can't be adding anything because my signs change there. So then if I look, if I ignore my signs for a second, 2 to 4, 4 to 8, 8 to 16, well, that looks like I'm kind of doubling, aren't I, right? I'm multiplying by 2. So this is our other common pattern, right? Where you're multiplying by a constant. However, I'm going from a negative to a positive, to a negative to a positive. So I'm not multiplying by just 2, I'm multiplying by -2, okay? So if you think about it, right? Here, a sub n, right? I'm multiplying by -2 over and over and over again, right? So if I'm multiplying by -2 over and over again, that means I'm going to use an exponent, right? So multiplying, that's how I describe my pattern, right? So this is adding by 1. This is multiplying by -2. So if I multiply by -2 over and over, that becomes the base of my exponent, right? And then, so here, multiply by -2, -2. So if I just do this as n, right? So that means it's -2 to the first power, and then -2 times, if I do this, 1, 2, 3, 4, that's always my n's, right? That never changes. So -2 to the first power would give me -2. 4 to the -2 to the second power would give me +4. -2 to the third power would give me, okay. So there we go. We're going to use exponential form, right? If we're multiplying by something over and over. And then last but not least, we have a sub 5, right? Which would be, if I multiply by -2 again, would be -32. So that's my a sub 5, okay? Now, let's look at this guy. Okay, so there's going to be ones like this on your homework. So I'm going to go to number 9. Take a look at number 9, right? we can see this is increasing, right? And I see 4, 8, 12. That looks like plus 4 to me, right? So we're adding 4 each time, right? So if you remember, that's kind of like your slope if we have an addition, right? Or a subtraction, okay? So that's gonna be my slope. So I'm gonna do a sub n equals 4n. That's my slope, always there. And then I'm gonna do my 0th term. So what comes right before this in this pattern? Well, if I, 4, 8, 12, if I go backwards and I subtract 4 to get the 0th term, right? The term that would come right before the first. So this is my a sub 1, a sub 2, a sub 3, a sub 4. So the 0th term, a sub 0, if you will be 0, won't it? So this would be plus 0. So a sub n is just 4n. And if you check it, this is 4 times 1, right? 4 times 2, 4 times 3, right? Because that's the third term, 4 times 4. And then our a sub 5 would be 4 times 5, which is 20, right? Which makes sense. Wouldn't that be 20 if I add another 4? Okay, so that's my pattern, all right? So there's gonna be a couple like that on your homework that you're gonna do and write the rule. Then, last but not least, okay, we're not gonna graph the sequence, okay? Don't worry about that. We're gonna talk about the sum of a series, okay? So a series, okay, is just when you take a sequence. So when you add a sequence, okay? So if you take a look here, here's a finite sequence, right? Then we have a finite series. So all we do is we take each of these terms and add them together, okay? If we have an infinite sequence, right, with these dot, dot, dots, and we want an infinite series, we really can't do that because we don't know when this ends, okay? So we will be looking for the sum of finite series, okay? So to find the sum, we're just gonna add them together. So literally, it's going to be written like this, okay? So all you're gonna do is 3 plus 5 plus 7 plus 9, okay? So this is what? 8, right? If we do, I believe this will be 24, right? But you can put it in your calculator, that's fine, okay? So we could just do 3, let's see if I did my math right. Yep, 24, okay? This guy is, I'm saying 18, but let's see, 3 plus 4 plus 5 plus 6, and there we go, it's 18. That's it, that's all you gotta do. Now, what I do wanna show you is the way I'm able to do those in my head relatively quickly is, if you take a look, and we're gonna do this more tomorrow, okay? You could just put this in your calculator for right now, but there's a little trick here. Do you see how this is increasing, this series is increasing by 1 each time, right? So if I see that each of my series, right, are increasing at a constant rate, so like see how this guy's increasing by 4, what you can do is you can actually do what's called, use the partial sums. So watch. Do you see how this is 4 plus 11? I'm taking the bookends, the first and the last term. 4 plus 11 is 15, right? Now watch. What's 5 plus 10? Oh, look at that. That's 15 too. 6 plus 9. What's that? Oh, that's 15 as well. And then here, that's 15 as well. So really, this turns out to be 15 times 4, right? Do you see how there's 1, 2, 3, 4, 5, 6, 7, 8? So I know there's 8 terms. So I'm gonna have exactly half, right? These partial sums, right? So if there's 8 terms, there's 4 sums of the first and the last term. So I just did, when I was doing these guys, I took the first and the last, right? So here 4 plus 11 gave me 15, and then I knew since there was 8 terms, there would be 4 partial sums. So 4 times 15 gave me, oops, equals 60. So that's how I got it. You can also just add them all together, that's fine too. But what you're gonna see tomorrow is we're gonna use that a formula that kind of mimics that. So here, if you look at this guy, what I did in my head is I said 3 plus 9, right, is 12. Then I had another 12, so this gave me 24, okay? So this guy, I would say, right, I would take my partial sum. You could also just add them. So this is what, 32? And then there's 1, 2, 3, 4, 5, 6, 7, right? Ooh, there's 7. So that means this 16 is gonna be like left out, right? If you think about your partial sums. So that means this is 3.5. So if I take 32 times 3.5, I get 112, right? Because there's 3.5 partial sums. You see how 16 is half of 32? Now, if you check it, 4 plus 8 plus 12 plus 16 plus 20 plus 24 plus 28. Look at that. It's 112, okay? So you can use my shortcut if you want, or you can just go ahead and add it all in your calculators, okay? But that's finding the sum, all right? So on your homework, you're gonna do a bunch of those, okay? And then tomorrow, we're gonna talk about 9-2, worksheet 9-2, all right? Hope you guys are doing well, all right? And happy Monday.